In this video, we will compare the stability characteristics of two types of cageable rough terrain forklift trucks for mining. The main difference between the two machines is how they steer. On the left is a machine that has an articulated frame for steering. The other machine is the Fl6000, which is equipped with a rigid frame and four-wheel steering. Rough terrain forklifts undergo various testing to ensure they are safe to operate. One of the tests carried out is a stability test as outlined in ASME B56.6-2002. Here is a brief rundown of how the test is usually carried out. A hydraulic tilt table is often used for this test. The machine to be tested is parked onto the table and the forks are loaded with the full capacity of the machine. The table is then tilted until the machine becomes unstable. The angle at which the machine became unstable is noted. If the angle at which the machine lost stability is less than what was required by the standard, then the machine failed the stability test. There are several tilt table tests to be carried out, and the machine is parked in various positions for each test. The test proves that a machine meets the stability requirements of the standard, but fails to show the potential dangers and unpredictability of articulated steering. The unpredictable nature of articulated steering is the main reason why manufacturers tend to build their machines with rigid frames. If you take an articulated forklift, load it to full capacity, and then observe where the center of gravity is located, you will notice that it is directly in line with the center line of the machine. However, once you steer the machine to full lock, you will note that the center of gravity not only shifts with the front of the machine, but continues to shift dangerously close to the edge of the machine. Now, why does this happen? It's not difficult to figure it out from this perspective. If you locate the center point of the rear axle and the center point of the front axle, draw a line over the 2 points. You now have the center line of the two axles. Ideally, the gross vehicle weight should be evenly distributed on either side of the line for optimum stability. Note that a great portion of the rear counterweight sits on the right side of the center line. Most of the load on the forks also sits on the right side of the center line. There's little on the other side of the line to properly balance the machine, and that is why the center of gravity has shifted to the right. In this precarious situation, it takes very little to cause the machine to upset. Even running over a small rock can cause an incident. The Fl6000 is a purpose-built underground forklift with a rigid frame. Steering is accomplished by four-wheel steer instead of articulation. The Fl6000 has the same width as the forklift truck shown in the previous example, but has a lower profile and a slightly lower center of gravity. Looking from above, you will note that the center of gravity is directly in line with the center line of the machine. Even when the steering wheel is turned to full lock, the center of gravity on the unit remains in line with its center line. The center of gravity of this machine does not shift as the operator turns the steering wheel, and therefore, the handling of the unit is more predictable. As a responsible manufacturer, we at MineCat feel it is important that forklift truck operators be made aware that even though both machines in this example can easily pass the stability test as outlined in the standard, sometimes there are operating characteristics of a machine that can pose danger to the operator's safety. Make sure you are aware of the operating parameters of your machine and be sure to never exceed them.